Hey everyone, hope you're able to hear me loud and clear. Yes, this is running on IST time zone. Am I audible to you? Am I audible? Because okay. Hi everyone, I welcome you all on behalf of Ajit-teaches. My name is Ajit Pal Singh Vadhavan. Okay, I will be a host for today's session, and in this I will be taking you through some of the common web application attacks. These attacks, which are very common in today's world, and this will help you in preparation of. So my main agenda, I will not go into much technicality of it, but the main agenda of this session is to acclimatize you and to make you aware of these attacks and to also help you in preparation for multiple infosec cert exams, because these are all parts of curriculum. The attacks that I'm covering today, these are part of curriculums, CSSP, of various certification courses, CSSP, CompTIA Security Plus, even CISA. So that will help you in that. And even at the same time, it will give you a good knowledge so that you can be protected against these kind of attacks. So let me start. The purpose of this session is to take you through web-based vulnerabilities. Okay, hope it is visible to you now. So web-based vulnerabilities, so there are different types of web-based vulnerabilities. Web-based vulnerabilities are those vulnerabilities which are designed to target your web applications. Web applications which are accessible through HTTP, which is very commonly used across the internet and our day-to-day life. So these weaknesses or flaws found in web application that attacker can exploit to gain unauthorized access to a data, systems, or entire network. Most of these vulnerabilities exist on server side, okay, they and some of them are exist on the client side also. So there are different types of web vulnerabilities that I will cover with you. First one is SQL injection, then cross-site scripting, cross-site request forgery, buffer overflow, malicious updates, race conditions, and injection attack. So what is SQL injection? SQL injection is one of the very common and oldest, I would say. But before I deep dive into, before I take you into SQL injection, let me explain you what exactly is injection. When I say injection, injection attacks are an attack where an attacker can input malicious data into the system, and this malicious data get accepted by the system in the absence of input validation and get executed and do things which an attacker wants it to do. So let's take an example. When someone is coming to our door, he ring the doorbell, you see who is outside, and then if he's known, then only you will allow him. You don't allow everyone to come inside. So same concept here. If you're not checking anyone, if you're not checking, then some malicious person can enter and do things, robberies, stealing. Same here. If in the absence of input validation, some data get executed, malicious data get executed and do things which an attacker wants it to do. So SQL injection is a web security vulnerability attack where an attacker can insert or inject malicious SQL statement in a query. So SQL is what? Structured query language. It is through this you can interact with web application. It is through this you would interact with your databases. You can interact, you can retrieve information, you can manipulate information, or even you can control the database. So in the absence of input validation, attacker can input malicious data, malicious SQL query, which get executed and do things which an attacker wants it to do. So how this works, the attacker input malicious SQL code into the web form or URL parameter, which is included into the query. If the input is not validated, the injected SQL code is executed and do things which an attacker wants it to do. There's a very good example I want to showcase it to you. Just give me a minute. Long way back, this happened in US. So this is a very good example of SQL injection attack, how someone can access your organization, can just a minute, it's coming up. Hmm. So if you see this car, if you see the front end of this car, it is covered with, this is a SQL query. So think about, let's take an example. This is a real incident which happened long way back, even 15, 20 years ago. So this car was over speeding on a highway. On highways, you have cameras. Cameras, high speed cameras. The speed cameras will detect the car is over speeding, and then it will instruct, the speed gun will detect that it is over speeding, and then it will instruct the camera to take a picture. And then this picture is being fed into the backend database to retrieve the information about you. And at that time, no one thought that someone will feed the database query using this in this manner. And this database query get executed in the backend database as there was no input validation, and it corrupted the whole database. So you see how a simple query on the number plate had trick our database and destroy the whole database. So this is one of the practical example of your SQL injection. How you can protect against SQL injection? One of the best way to protect against SQL injection is your regularly update and patch. This is one of the, means there are two things which are very, very commonly used as a protection. One is regular update and patching. Regular update and patch database systems to fix vulnerability that could be exploited by SQL injection. Limit the account privileges. So normally what happens, okay, when I say account privilege, normally we follow the three-tier architecture. You have front end, then you have a middle tier, and then you have a back end. Okay. So when I say limit account privileges, if middle tier only need read-only access, then why to give read-write access? Don't give read-write access. Only give read-only access if it is required. Validate inputs in each and every cases, because that is kind of a Swiss knife army. Like, and then use stored procedures. What is stored procedures? Like I take classes with lot many vendors. Like I take class with one of the such vendor, one vendor, where I join the class in a specific time. There is a learning success manager. He will give me access, and then only I can access. So there is a defined procedure to take a class. So similarly, a small programs are being written with the help of which the middle tier or front end can access the database. So allow only database to be accessed using a defined procedure. If someone tries to access it using some other manner, don't allow. So these are some of the ways by which you can protect against SQL injection attack. SQL injection attack in a nutshell It is an attack where attacker inject malicious SQL query into the database, which get executed in the absence of input validation and do things which an attacker wants it to do. This is one of the common attacks which is being used, common and oldest attack which attackers are using to against the database engine. Next one is about cross-site scripting. I will explain this in a very, very simple manner. Okay. Before I deep dive into it, let me take you. Okay. So how cross-site scripting work? Let me explain you in a very simplest manner. Suppose this is an application, which is abc.com. And this application has cross-site scripting vulnerability. Cross-site is represented by XSS. And this has cross-site scripting vulnerability in it. So this vulnerability allows hacker, this is hacker, to inject malicious data, malicious query, malicious code. So hacker has injected malicious code here. What is this code? Suppose let's take an example, XYZ. So this code stays on a system or persists on a system. Now, if the normal user, like A, B, C, this is normal user 1, 2, 3. When they try accessing this website abc.com, then this malicious code, which has been injected by hacker XYZ, it get executed on user browser and do things which an attacker wants it to do, maybe steal cookies, steal data, or even website defacement. Lot many times we see that Indian hackers have defaced the Pakistani government website, or Pakistani hackers have defaced the Pakistani Indian website. One of the method they use, one of the vulnerability they exploit is cross-site scripting vulnerability. So in a simplest manner, if this vulnerability exists, this allows attacker to inject malicious code into the website. And when the normal user access this website, which has been injected with malicious code, then this malicious code get executed on a user browser and do things which an attacker wants it to do. This is we called as cross-site scripting. So let me explain you with the help of slides. So injecting, it involves injecting malicious code into otherwise benign and trusted websites. So like you see, there was a website abc.com where hacker had injected a malicious code. So it occurs when attacker uses a web application to send malicious code, typically in the form of a website browser side script, to the different end user. It enables attackers to inject script into web pages viewed by end users. So you see the illustration of it. Our web application abc.com is hosted on a server with XSS vulnerability. Like I've already explained it to you. So this vulnerability allows hacker to inject malicious script into the web server. So like hacker has injected a malicious script XYZ. The attacker leverages the XSS vulnerability to insert harmful script into the web application. And when other users access this web application abc.com, the injected malicious script executes on the user browser, and this steals valuable information and perform any designated task. So there are two types of vulnerabilities, two types of cross-site scripting vulnerability. One is persistent, non-persistent, or reflected. One we call it as reflected or non-persistent. Reflected or non-persistent. And second one is non-reflected or persistent. So what is this? I tell you. Long wave means, I give you an example of reflected. What, suppose a hacker had in this reflected one, hacker sends you a phishing email. Hacker sends you a phishing email which has a link in it. Hacker sends you a phishing email which has a link in it, and that link has some script hidden inside it. And when you click that link, it will take you, it will, that script get executed, or it will redirect you to malicious website. So this is we call as a reflected or non-persistent. I give you a example of a spectacle example of it. In 2021, Government of India has deactivated Aadhaar card number of lot of fake people. So we were getting emails. We started getting phishing emails that please check whether your Aadhaar card is there in that deactivated list or not. So I have clicked that. And so I looked at that email and I found that it has a link which has a script hidden inside it. So this is we call as a reflected or non-persistent. Then you have a non-reflected or persistent. Persistent means where data, it is directed at those websites, forums, blogs, which allow you to input data, and that data stays for a longer time over there, like blogs, forums, LinkedIn, etc. So let me give you an example of persistent. Suppose there is a website. Let's take an example, LinkedIn. And I have written one post here, 100% pass guarantee, CISSP, pass guarantee. And I have hidden one malicious script, XYZ, inside it. Now, I am not sending any redirect link. I'm not sending any redirect link. I've just written a post. This is an hypothetical example because LinkedIn, if you try inputting or putting some script, putting some link or post which has link in it, it will not let you put it. But yes, because input validation is there, but just an hypothetical example. So I have written a post on LinkedIn where I have written a post 100% pass CSSP guarantee, and I have hidden a XYZ script, which is malicious script, which can steal your cookies and steal your data. Now you will yourself search for, because when we prepare for exam, we look out for DUMs and all that. And I come across this, someone come across this post and he access it. So this XYZ script get executed on the browsers and do things which an attacker wants it to do. So there are two types of cross-site scripting, non-persistent or reflected. In a reflected, using a phishing email or even smishing also, using a phishing email or even phishing, someone sends you a mail or a link which has a script hidden inside it. And when you execute, when you click that link, it may redirect you to the malicious website or that malicious script get execute. Then we have persistent, where which directly targets forums where you input data and data gets stored for a longer duration. Like I have written a post on LinkedIn 4 years ago, that post is still there. So I have written a post. Suppose let's take an example. I write one post, 100% CSSP pass guarantee, and hide one script and embed one malicious script into that post. People will themselves come looking for that post, and when they click, when they try to read it, the script which is hidden inside it will get executed and do things which an attacker wants it to do. So this is an example of XSS. Okay. So how you can protect against? So what are the impact of XSS? XSS can allow attacker to hijack your sessions. It can allow hackers to steal session cookies, enabling them to impersonate the user and gain unauthorized access to their accounts or sensitive data. It can allow you to deploy the hostile content. Attacker can use XSS to inject and deploy malicious content such as fraudulent forms or ads which can compromise the system integrity. It can impersonate the user. Attacker can act as if they are the legitimate user accessing and manipulating data on behalf of the user without their consent, and definitely are phishing. How you can prevent? Don't allow anything, everything to be uploaded. Like try feeding, try posting something with on LinkedIn which has script in it. No, it will not let you. Follow the proper coding practices and review. Adopt secure coding practices. Involve validating and sanitizing all user inputs and output. Implementing input validation. Input validation, I also always mention, it is like a Swiss knife protection for every every application attack. And update and patch. Update and patch your systems regularly. That is what you require. Now, CSRF. Sometimes people get confused between cross-site scripting and cross-site recurse forgery. They think they are pretty similar in nature or kind of dependent or kind of related to each other. No, they're different. So whenever you see trust exploitation, mutual trust exploitation, authentication, then that is always cross-site request forgery. So let me explain you how this actually work. Then I will take you through a slide. Although practically these days cross-site request forgery is not very much possible. Suppose there is a website. Suppose there is a banking website. I will call it as xyz.com. This banking website only authenticate user once. Only authenticate user once. Okay. Which means that, in banking websites, first you get authenticated. Now, after that, if you want to add pay, delete pay, transfer money, you need you need to authenticate multiple times. But this website only authenticate once, which means that once you authenticate it, you can transfer money, you can withdraw, you can transfer money, you can add pay, anything you can do. Another thing, no expiration time set. Okay, no expiration time set, which means that if you have login, if you have logged in, then if you have forgot to log off, then you will continue logged in. Okay, so this is how. So these are the two things which are breeding ground for cross-site request forgery. Suppose I logged in. Suppose a user, Ajit, logged in. And I forgot to log off. Okay. At the same time, I opened another website, abc.com, which is a malicious website. We open torrent website and any other website, which is a malicious website. And it has malware in it. Okay. Now this malware finds out that session is opened in which this user has logged in. So it will take control over this session of Ajit session, and it will make a request to transfer one $10,000 to abc.com. $10,000 to abc.com. This xyz.com will think it is Ajit who is making a request because Ajit is already logged in. So this xyz.com think it is Ajit who is making a request, but in reality, it is this abc.com which is making the request and it will transfer the request. So this is how cross-site request forgery works. So you see, these attacks exploit unintended behavior that are legitimate within defined use. So ABC has requested to transfer money, which is very much legitimate. But in reality, it was requested by ABC and under the disguise of Ajit. But and this is wrong. So they are executed against sites with authenticated users, like here in this case, Ajit, leveraging the site's trust from the prior authentication event. So in this case, it was ABC had leveraged the site's trust from the prior authentication event where Ajit has logged in. So thereby tricking the user browser into sending an HTTP request to the target site, thereby exploiting this trust. So let's take an example. Suppose a bank allows user to perform transaction without re-authenticating each time, like Ajit logged in, and after that, he doesn't need to it doesn't need to re-authenticate. The user opens a banking application and authenticates with the banking website. Ajit authenticate with your xyz.com. If the user remains logged in, Ajit logged in, and does not close the browser, then another browser tab, which is he has opened to xyz.com, which could send a hidden request to the bank, resulting in a transaction that appears to authorize but was not initiated by the user. So this transaction of transferring of $10,000 will get successfully as it is initiated by user, but in reality, it is initiated by malicious application in a different web browser. So this is what we call it CSRF. So it has nothing to do with accesses. Accesses is quite different. So how you can protect? Okay, train and maintain awareness, educate users about the risk associated with CSRF attack. Attacker can lead to better coding practices and user behavior. Scan and test your applications regularly. I remember during one such training, someone asked me how we can identify XSS, CSRF, and these vulnerabilities. You can do it manually also, but for that you should have experience. Otherwise, there are VAPT tools, vulnerability assessment penetration tools like College Guard, Nessus, with the help of which you can easily find it out. Limit authentication time. Okay, don't allow for infinite authentication and set cookie expirations. So this is about your CSRF. Next one is about buffer overflow, which is very commonly. It is buffer is what? Every program needs a memory. Okay, every program needs a memory to work. Correct? So it has a memory attached to it and allocated to it. So let's take an example. You have 25 liters water bucket in your bathroom. You input 30 liters water into it. What will happen? That 5-liter water will overflow and it will wet the flow. So same here. There are two programs. Okay, let's take an example. Okay, so let's take an example. There is an there is a program which has two modules, A and then B. Both has 20 MB space allocated to it. Okay. Now, in the absence of input validation, This user A has input 30 MB data. So now this 30 MB data is inside. So it only have 20 MB. So it will encroach this 10 MB will encroach the space here, and now it is left with 10 MB. So now when user B input 20 MB, this will not have space to execute. So this is what a buffer overflow attack is. You input more data, which than what your buffer can handle. It occurs when a more data is placed into the fixed length buffer before that it can handle. So this extra information overflow into the adjacent memory space, corrupting or overwriting the data it held there. So buffer overflow example of it in January 2003, there was one vulnerability detected in Microsoft SQL Server. So there was a slammer worm. What it does, it explodes the memory area of a SQL server, making and encroach the spaces of another program. You might have seen, if you try to understand with the help of analogy, there is a video available on internet when you put Mentos into a Coke bottle, the Coke bottle explodes and spread everywhere. And same here, this worm you input into the memory, you inject into the SQL server memory, and memory explode, and then it generate a flood of network traffic as it attempts to infect the other servers. The reasons for buffer overflow: poor programming practices. Developers may not adhere to best coding practices, such as correctly managing buffer size or failing to check for overflows. There are programming languages like C, C++, which has this inherent vulnerability because they do not automatically enforce bounds on arrays of buffers. And again, as I told you, one of the main reason is input validation. If you like, you might have noticed that there is a limit on the number of characters you can add in an address field of many forms, 30 to 40 characters. That is to protect against buffer overflow and poor management of memory allocations. How you can protect against proper coding practices. Developers should follow secure coding guidelines such as using safe functions that limit buffer size, do the review regularly, do the regular code reviews, or there are manual code reviews, and you can also go for automated code reviews and proper input validations. Then we have malicious update. Malicious update, the best example, although they have not accepted that as a malicious update, that what happened in CrowdStrike. They said that it was some problem, but still it is not very easy to digest that one thing which is not malicious has caused a chaos in the industry in the world. So although let's not go down that way. So it occurs, the malicious update occurs when attacker exploit the software update process to distribute malware or compromise the systems. So attacker disguise malicious code as a routine update, exploiting the normal update process. So you see the example of it. In 2000, very similar to CrowdStrike, although CrowdStrike has gone berserk, means very wide. It has caused a great issue around the world, but malicious update, it caused problems in the among the customers of CC Cleaner only. So in 2017, our CC Cleaner, a popular utility software for cleaning and optimizing computer, was compromised when hackers breached the supply chain of its parent company. The hacker injected malicious code into the legitimate CC Cleaner software update. This compromised update was then distributed to the millions of users. That's a problem. Once installed, the hidden malware provide hackers with the unauthorized access to the infected systems. So how you can protect? Use secure channels for update. Ensure that software updates are delivered over secure HTTPS to protect against interception. Verify updates with digital signatures. Lot many times you noticed When you download something, it gives you an error that publisher of this is not verified. Why so? Because they try to verify the digital signature of the publisher by decrypting it using the public key of the publisher. If not, then they will give you a warning. Now it's up to you whether you want to download and execute it or not. And educating user about the risk of updates. So that's the reason the security awareness training is being conducted regularly, where they where they tell you and emphasize the importance of updates and download from the authorized sites. The last one then is race condition. Race condition occurs is a situation where two or more process or threads attempts to change the shared data at the same time. Let's take a very simple example. You have 10,000 rupees in your account. Your wife and you have a joint account. Both of you try to take 6,000 at the same time, thinking about you have 10,000. And if it get executed at the same time, it's a problem. So this illustrates the time of check of time of use data. Another example, suppose you are today's what, 5th of August. You are looking at the last month inventory. You are the head. You are looking at last month inventory of a data because it's your this is your regular task. While you're updating, while you're reviewing the last month or reading the last month data, someone has executed, someone has forgot to input some data and he has executed the data in it and he has written something into it. So that is we called as a race condition. That's a problem these days. Okay. So race condition, okay, this is an example. So it takes a time of check. It exploits the time of check, time of use vulnerability. Another example of it, like there are two people, lot many times you have seen the airline uh, overbooking happens. So someone is trying to book the ticket and he found that ticket is available and he's trying to book the ticket, and within that, if race condition exists, someone else books it. So this result in a overbooking of the thing. So that is how race condition works. So this is also not a good thing. So these are some of the web application vulnerabilities and how you can protect against web application vulnerability. There is no one size fits all approach. Although there are tools available with the help of which you can detect it, but I would say the following the proper coding practices and regular VAPT performance, regularly performing the VAPT, validation and sanitization. This is one of the best approach. Implement rigorous input validation to ensure that all user input confirms the expected formats. Try entering 32 in a date form because it will not take it because it is validating the input. Try entering 50 characters in a form field. It will not take it because it is validating the input. Follow the strong authentication method wherever possible. Use multi-factor authentication or passwordless authentication. Regularly patch your application and regular code. Follow the secure coding practices. Perform regular code reviews and a regular testing. These are some of the controls available to protect you against web application attacks. I've not gone into technicality. I've explained you the concepts. This can help you in certification exams like CISSP. This is a part of domain 8 of CISSP. Then this will also help you in your CompTIA Security Plus, CISA, CISM, anywhere. Okay. So thank you very much. Any questions? Anyone? Feel free to ask. No? So thank you for joining everyone.